Hello all, good morning, welcome to Unacademy. See, listen to our new anthem, Crack GATE ESE with India's largest learning platform. Get Plus subscription access unlimited live and recorded courses from the India's best educators. So here, get subscription. So before going to start this, let me introduce myself. About me, I, myself Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now here, go to your Unacademy's learning app and take the subscription plan. Here, get subscription. So you can take the get subscription plan here. See what you will get for the plus subscription. You will get the daily live classes, live tests and quizzes, structured courses, unlimited access you will get for the plus courses, plus subscription. Now for the iconic subscription, here you will get the personal coach, main Q&A practice test, then study tracker, all benefits of plus. Okay, so this is very important subscription plan here, iconic subscription to take your GATE and ESE preparation to the next level with the help of personal coach. Okay, so in that iconic subscription you will get all these benefits. First, personal coach you will get, so get one guidance from the top exam experts as your personal coach, align your preparation strategy and learning resources. Then mains and QA practice, strengthen your mains answers writing through regular practice with the evaluation and personalized feedback. So study tracker, participate in study tracker plan and study booster workshops. Evaluate your progress in bi-weekly review with the personal coach, and all the benefits of plus subscription also you will get here in the iconic subscription. Now what is the plus subscription here? So daily live classes is here, live test and quizzes, then structure courses you will get. So chat with your educators, engage with in a discussion, ask your doubts and answer the polls all while the class is going on. Now live test and quizzes, evaluate your preparation with your regular mock test and quizzes and get detailed analysis on your performance. Now structure courses, all your courses are structured in line with your exam syllabus to help the best preparation for it. Okay, unlimited access. When subscription gets you access to all live recorded courses to watch from the comfort of any of your devices. Now you learn with the top educators. You can see the top educators here for the mechanical engineering, for the system here CS and IT. So you will get the top educators. So you will get a benefit for this. So for everybody is there, for the civil engineering, for the engineering mathematics, everybody is will be here to get to educate you. So take a advantage of this educators. See No. For the GATE and ESE, batches and year-long courses, 30 courses are there. Mechanical engineering, 24 courses are available. Electrical engineering, so everything is given detail here. So chemical engineering for mathematics is also there is one course. So you can see the different courses for GATE and ESE. Here plus subscription, you can select the plus subscription plan. Here select plus and select iconic. So see, for every subscription plan it has different benefits. So basic plans to get you started with your plus subscription. Here India's best educators you will get, and then interactive live classes you will get, structured courses and PDFs you will get, live test and quizzes also you will get in the plus subscription. And in an iconic subscription you will get the best, so all the benefits of plus subscription are also added in the iconic subscription. And the most important things in iconic subscription are you will get the personal coach, personalized test analysis, study planner you will get, and preparatory study material also you will get for the iconic subscription. So please take any subscription plan here, either plus subscription or for iconic subscription, it is up to you. So it has different benefits. If you take iconic subscription, you will get the most uh, important benefits here to take your study at the higher level. Okay, now the plus subscription plan, here you can see for the plus subscription you can take for either for 1 month, 3 months, 6 months, but I will suggest you go for the 12 months plan. See here, you can see the subscription fees here for the plus subscription and also for the iconic subscription. Now see, the iconic subscription for the 12 months and everything is here given for plus subscription. So the different depending upon the months, and it is EMI facility is also available to pay your subscription fees here. Now iconic plan, you can see for the iconic for 12 months it is 50,000. So if we use here my promo code, so here you will get my promo code, that is DSP, to get the 10% discount on your any subscription plan. You can use my promo code DSP to get the 10% discount on your subscription plan. Okay, now let's start our actual topic. From now, here discrete mathematics, we'll take the next lecture on that. That is, this is our 15th lecture on discrete mathematics. Okay, now that is graph theory and the second lecture on graph theory. Okay, so here we will see in the last lecture we will see how to the basic concepts of graph theory. That is for here you will see in the last lecture we have studied what you mean by graph, then the types of graph, pseudo graph, then null graph, complement of a graph, sorry, a complete graph, complete bipartite graph, everything we covered in the last lecture. Now in this lecture you can see the subgraphs. What do you mean by subgraphs here? So you can see the subgraphs here. Let G is equal to, definition of a subgraph, let G is equal to VE be a graph with a graph with H with vertex set of V dash and H set of E dash. It's said to be a subgraph of G if E dash is a subset of E and V dash is a subset of V, such that the edges in E dash are in incident only with the vertices in V. So exactly similar way here we will find out the, see, I will give you an example where this is a graph and this is subgraph of this graph. Okay, now suppose this is your graph. Here is, suppose we can start with AB. Okay, this is your vertex A, this is your vertex B, and you can take the vertex C over here, right? So vertex C, then vertex here D, suppose here is vertex E, suppose here is vertex F, okay, and here is vertex G. So this is your graph G. Now what do you mean by subgraph of G? Now 8 sets are here: E1, E2, E3, E4, E5, E6, E7. There are E7 edges here. So our graph G. Now we can say that the subgraph of, we can plot the subgraph of here of this graph G. So G, B, C and D. I'm taking this graph. So G, B, C and D. So here is E. Okay, so here B, E2, E3, E4, E5. Okay, E2, E3, E4, E5. You can see here. So graph G, A. So this is a subgraph of G. This is your subgraph of G. Suppose here this is called as H1. So H1 is a subgraph of G. As you see here, the vertex set of H1 is a subset of vertex set of G, and edge set of here H1 is a subset of edge set of G. Therefore, H1 is a subgraph of G. H1 is a subgraph of G. Right? Very simple definition. Subgraph. H1 is a subgraph of G. Now, we go from spanning subgraph. Okay, what do you mean by spanning subgraph? A subgraph of G is said to be spanning subgraph of G if it contains all the vertices of G. It contains all the vertices of G, but not necessarily it contains all the edges of G. Okay, now suppose I'm taking this is your graph. Okay, this is your graph. Okay, so here is A, B, C, D, E, F, G. Okay, so this is your graph. Now we can see that it must contain all the vertices. Right? It must contain all the vertices. A subgroup of G is said to be a spanning subgraph of G. A subgraph of G, not subgroup. A subgraph of G is said to be a spanning subgraph of G if it contains all the vertices of G. It means it contains all the vertices. Here. So here is A, B, C, D, E, F, G. Right? So this is a subgraph of G is said to be spanning subgraph if it contains all the vertices of G. It must contain all the vertices of G. Okay. So this is your spanning subgraph of G. Okay. So this is your graph G and we called as H2 here. H2 is a spanning subgraph of G. H2 is spanning subgraph of G. Right? H2 is a spanning subgraph of G. A subgraph of G is said to be a spanning subgraph if it contains all the vertices of G. Right? If it contains all the vertices of G, and it must be a subgraph and it covers all the vertices, but not necessarily all the edges will covered. Okay, so this is your spanning subgraph of G. Okay, now next is complement of a subgraph. What do you mean by complement of a subgraph? The complement of a subgraph H1 is equal to V dash E dash with respect to the graph G is another subgraph. Okay, and H2 is V double dash E double dash such that E double dash is equal to E minus E dash and contains only those vertices which has endpoints of E dash. Okay, so complement of a graph. Suppose if I am taking this case will be more clear to you. So this is A, B, C, D, and here is E, here is B, okay. So this is your graph G. So you will get the complement of a graph. All the vertices are covered, right? A2, all the vertices are covered. A, B, C. So here we'll take the vertices A, B, C, D, E, right? Now there is an edge from A to B. In G complement, it means G dash. Here complement is denoted by G dash. G dash does not contain as there is a edge. A to B is edge, right? So there is no edge in G dash A to B, but A to C is not edge. So here we can take the edge, right? C to D is edge, so we cannot take here. But A to D is there is no edge, so we can take its edge. Now E to E there is no direct edge, so we can take it in a complement. E to B is edge, E to C is edge, so we cannot take. E to D is also edge, so we cannot take. Okay. Now B to A is edge, B to C, so B to C, so B to D. Yeah, so every vertex is covered here, and this is the complement of a graph, subgraph. Okay, this is complement of a subgraph. Now all the vertices are covered, and the edges here, if there is a edge in G, then there is no edge in G dash. If here is no edge in G, so there is edge in G dash, right? G and G dash. So G dash is a complement of a subgraph. Okay, now suppose here A, B, C, E, suppose, and here is your graph. So complement of this subgraph is like this. Suppose if I do A, B, C, A, B, A, B, C, E. Okay. AC is not a, there is no edge in AC, right? There is, here is edge in AC. Then AE. Then BCH, BAH, BE, right? Then CEH, so here is no edge. CAH, CBH, so here is no H, right? And E to B, E to C only H. So E to BH, E to AH. So this is your complement of H, right? This is H complement. Here, now factors of a graph. So a K factor of a graph is defined to be a spanning subgraph of the graph with the degree of each of its vertices being K. It is K factor is a K regular graph. Okay, K factor is a regular of degree K. So we will take one any factor. So spanning subgraph, it means it covers all the vertices, right? And with the factors, suppose this is your graph. Okay. Okay, this is your graph. Suppose here is V1, V2, V3, V4, V5 and V6. All the vertices must covered. Now this is any graph. Here is no any restriction to draw the graph, but I am trying. Here degree of every vertex will be 5. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this is your graph G. Okay. Now one factor. We'll say one factor of the graph. First we will draw the all the vertices because it is a spanning subgraph. Right? So all the vertices must cover. V1, V2, V3, V4, V5, V6. You will get many K factors graph here. See, suppose. So degree of every vertex must be 1. So this is your one factor graph. Okay, one factor. one factor of graph, right? So you will get more one factor graph here. See, suppose this is against 6 vertices and one factor graph like this. Yes, every vertex of degree 1, V1, V2, V3, V4, V5, V6. This is also one factor graph. Okay, one factor graph. No, third one. Two factor graph. So degree of every vertex will be true. Sorry, the degree of every vertex is 2. So two factor graph you will see. So degree of every vertex is 2. So you will get degree of every vertex is 2. Like see, 1, 2, you will see. Here is 1, 2, 3, 4, 5, 6. Right? Degree of every vertex is 2. Here is degree 2. V1, V2, V3, V4, V5, V6. Right? So here degree of V1, V2 is 2. Degree 2. Here degree 2. Here is degree 2. Here is degree 2. Now here is degree 2. So this is your two factor graph. Right? Two factor graph. Degree of every vertex is 2. This is your two factor graph. Okay. So we can say by using this, every odd complete graph is two factorable. Every odd complete graph is two factorable. Every odd complete graph is two factorable, right? You can say that every odd complete graph is two factorable. Okay, it means we cannot find out the one factor graph for this. For example, suppose these are your 5 factors, right? So how you can find out a one factor graph? No, it is not possible. But you can see that here you can draw a two factor graph, right? Degree of every vertex is 2. Yes, so every odd complete graph is a two factorable, right? Now, next we move further. Isomorphism. So what you mean by isomorphism? Let's see. Isomorphism of a graph. Two graphs G1 and G2. Isomorphism of a groups we have seen in the previous lecture, right? Now here isomorphism of a graph. Okay. So isomorphism, two graphs G1 and G2 are said to be isomorphic if there is one correspondence between their vertices and between their edges such that the incidences are preserved. Okay, so such that their incidences are preserved. In other words, two graphs are isomorphic if first one, the number of vertices are same. Second, the number of edges if the edges are same. Okay, and number of not if the edges are number of edges are same. Yeah. Number of vertices are same, number of edges are same, and if G1 has n vertices of degree k, then G2 must have exactly n vertices of degree k, and adjacency preserved. If conditions above are satisfied, then we say that the two graphs G1 and G2 are isomorphic. It means to get that isomorphic graphs, the number of vertices in G1, suppose G1 and G2 are isomorphic, we have to prove that G1 and G2 are isomorphic. So number of vertices in both the graphs must be same. Number of edges in both the graphs must be same. Okay, the number of vertices of having degree k is same in both the vertices, both the graphs. Okay, and adjacency preservancy. Okay, so we will see one example how the graphs are isomorphic. Okay, suppose this is your graph on 4 vertices, A1, B1, C1, D1, right? So here A1 to B1 is edge, A2 to A1 to D1 is edge, then A1 to C1 is D1 to C1 is edge, B1 to C1 is edge, and here is edge from B1 to D1 and A1 to C1. Okay, this is your graph G1. Now, graph G2, you can see here graph G2. Suppose this is so here is A2, D2, C2 and B2. Now we have to check whether G1 and G2 are isomorphic. Okay, so first case. So number of vertices in G1, number of vertices in G1 are 4. Okay, number of edges. We will what we will do for G1 and G2, we will write down in a 2 points. Okay, for G1 and for G2. Okay, first one. First case, number of vertices are 4. First one, number of vertices are 4. Second one, number of edges 1, 2, 3, 4, 5, 6. Number of edges 6. Here 1, 2, 3, 4, 5, 6. So number of edges are 6. Number of edges are 6. Right? Third case. Which one is the third one? So number of degree vertices. So how many vertices have having degree 3? 1, 2, 3 and 4. 4 vertices of degree 3. 4 vertices of degree 3. Okay. Here is third one. 1, 2, 3, 4. All the 4 vertices having degree 3. So 4 vertices of degree 3. Okay, number of edges are same, number of vertices are same. So fourth condition, adjacency preservancy. So how we can preserve the adjacency relationship here? So fourth case I'm writing here. So adjacency relationship. Okay, so fourth point we will write here. Okay, A1 is adjacent with C1. Similarly here A2 is adjacent with C2. B1 is adjacent with C1. Similarly, B2 is adjacent with C2. So in that way, you can see, prove the adjacency relationship. Okay. So D1 is adjacent with B1. Here D2 is adjacent with B2. So here C1 is adjacent with B1. C2 is adjacent with B2. So in that way, you can preserve the adjacency relationship. Okay, so therefore the graph G1 and G2 are isomorphic. Are you getting it? Graph G1 and G2 are isomorphic because it preserves all the properties of isomorphism. First is number of vertices are same. Second is number of edges are same in both the graphs. Third one is there are 4 vertices of degree 3 in G1 and also there are 4 vertices of degree 3 in G2. And adjacency relationship also preserved. Here A1 C1 adjacent, here A2 C2 adjacent. So here A1 C2, B1 C2, in that way we can preserve the adjacency relationship. Okay, so therefore these two graphs are isomorphic. Now find whether, now see we will check whether this, find whether K6 and K33 are isomorphic or not. Okay, we know that what you mean by K6 in yesterday's lecture we have seen. Okay, in previous lecture on graph theory we have seen what you mean by complete graph on n vertices. So Kn denote the complete graph on 6 vertices. So complete graph on 6 vertices, it means degree of every vertex in a complete graph is n minus 1. Now here complete graph on 6 vertices. So degree of every vertex must be n minus 1, that is 5. Right? So we will see. So there are 6 vertices. 1, 2, 3, 4, 5, 6. Okay. There are 6 vertices of degree complete graph. So K6 we will see here. So K6 is equal to So degree of every vertex must be n minus 1. So here n is equal to 6. So degree of every vertex is 6 minus 1, that is 5. So complete graph on 6 vertices. One, 2, 3, 4, 5. 1, 2, 3, 4. And here is 5. So degree of every vertex is 5. Yes. Here is 5, degree 5. 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So in a complete graph on 6 vertices, degree of every vertex is n minus 1. That is 5 minus 1 is 6 minus 1 is 5. Okay. Now this is your case 6. Now K33, complete bipartite graph. Okay. So vertex at V1 contains 3 vertices. This is Mn. Vertex at V1 contains 3 vertices. Vertex at V2 also contains 3 vertices. So complete bipartite graph. So here degree of every vertex is 3. Complete bipartite graph, it means what? There is an edge between every vertex of V1 to the every vertex of V2. Right? And there is no edge between any two vertices of V1 and any two vertices of V2. Right? This is your complete bipartite graph. Now we have to check whether these two graphs are isomorphic or not. Okay, so first property K6 and K1. So here, first is number of vertices are same. Okay, how we can calculate the number of edges in a complete graph? So there are number of edges in a complete graph is n into n minus 1 by 2, right? So here 6 into 6 minus 1, 5 by 2. That is 15 edges. You can count it. So there are 15 edges in a complete graph of 6 vertices. Now the number of edges in a KMN, so you will get it, the number of edges in a KMN is m into n, right? So here 3 into 3, which is 9 edges. See, as the number of edges are not same, and obviously here we can see the degree of every vertex is also not same. Here degree of every vertex is 5. Here degree of every vertex is 3. Right? So these two graphs are not isomorphic. So K33 and K6 are not isomorphic. Okay? So we can say that K6 and K33 are not isomorphic. Clear? K33 and K6 are not isomorphic. Okay. Next, we'll check. Show that the following graphs are isomorphic. Okay. So show that. Show that it means they must have a isomorphic graphs. So show that the following graphs. Show that the following graphs are isomorphic. Following graph are isomorphic. Okay. So the graphs are given to you. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4, 5. So F1, G1, we'll see. Hmm? Now this is show that the following graphs are isomorphic. So how to show that these two graphs are isomorphic? Let's see. Here is A1, B1, C1, D1, E1, and F1, G1, H1, G1, H1, and I1 and C1. Okay, this is your graph G1, capital G1. Now G2 is given. Now this is here F2, G2, H2, I2, and Z2. Okay, now here is A2, B2, C2, D2, and E2. Okay, so E2 to B2H, E2 to C2H, A2 to D2H, here A2 to C2H. Then which one is remaining? B2 to D2H. Okay, so this is your graph. Now check whether these two graphs are isomorphic or not. Okay, so here we draw F2. Here is G2, right, and here is A2. Okay? Not up to G2, here is up to C2. Right, now this is your graph G2. Now check whether the number of vertices in both the graphs are same or not. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 plus 5, 10. Okay, 10 vertices are here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So number of vertices are same in both the graphs. Okay, number of vertices are same and number of edges are same. So G1 and G2 will say, check whether G1 and G2 are isomorphic or not. So number of edges, degree of every vertex is 3. Yes, the number of vertices are same in graph G1 and G2, right? So here 1, 2, 3, 1, 2, 3, 1, 2, 3. So number of edges are also same. No, number of edges are not same. Now we'll see here E1, A1, A1, B1, E1, D1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Number of edges you can see here. In the graph G2, the number of edges are 15. And in the graph in the graph G1, the number of edges are 15. Number of edges are and number of vertices are same in both the graphs. Okay, 10, 10. Number of vertices in graph G1 is 10. Number of vertices in graph G2 is 10. Now the number of edges in graph G1 are 50. Number of edges in a graph G2 are 50. But degree of every vertex in G1 is not same. Now degree of A1 is here uh, 2. Number of vertices. How many number of vertices? In G1, degree of each vertex is 3. And is in G2, the degree of each vertex is, now graph G1, right, degree of each vertex is 3. Here is also degree of each vertex is 3. Now, but also here the graph G1 and G2 also adjacency preserved. G1 is equal to G2. So adjacency preserved, yes. A1 F1H, here A2 F2H. So we can say that A1 to F2 is the adjacency relationship. A1 to F2, right? Here we can see that B1 to G2 is the adjacency. Then C1 to here C1 to H1, C2 to H2, so C1 to H2 is the adjacency. C1 to H2 is the adjacency. Then C2 to, similarly we can find out D1 to I2 is the adjacency. D2 to, here you will get D2 to I1 to D1 is the adjacency. Okay. Similarly E1 to Z2 is the adjacency. Then G1 to B2 is the adjacency. Then H1 to C2 is the adjacency. Then I1 to D2, sorry, ho gaya. Then J1 to E2 is also adjacency. And then G1, therefore G1 is isomorphic to G2. Okay, therefore G1 is isomorphic to G2. So we can say that these two graphs are isomorphic as the number of vertices in both the graphs are same, number of edges in both the graphs are same, number of vertices having degree 3, both the graphs are having the vertices of degree 3 are same. So, and the adjacency also preserved. So G1 is isomorphic to G2. Okay. Now next is operations on graph. Very important. Operations on graph. Union of two graphs. Okay. So here union of a graph, we can say that. So for graph G and G star. Okay. For the graph G and G star. So see. The union G star is a graph whose vertex set is V union V star and edge set is E union E star. Okay, union of the graphs. But for the graphs G and G star, G union G star is a graph whose vertex set is V union V star and edge set is E union E star. Okay, so we will take one example in which all the operations will covered in the one example only. Okay, so we will go further here. Now intersection of two graphs. For G and G star, next operation is intersection of two graphs. For the graph G and G star, intersection G star is a graph whose vertex set is V intersection V star and edge set is E intersection A star. It means the edges which are common in both graphs only comes in the intersection of these graphs. Okay. Now ring sum of a graphs. For the graphs G and G star, the ring sum G star is a graph whose vertex set is V union V star and the edge set is the set of those edges which are either in G or in G star but not in both. It means intersection में जो भी edges आने वाले वो हम लोग यहाँ पे ring sum में नहीं लेने वाले, right? So जो भी edges which are in intersection, that edges will not come in the ring sum of a graph. Okay, so we'll take one example of the graph in which we define all the operations, that is union, intersection and ring sum. Okay, so let's draw one graph here. Suppose this is your graph A1 to B1, right? Here E1, edge E1, here is edge E2, B1, D1, C1, E4, E3, E4, E5. Okay, this is your graph G. Now graph G star will say, this is F. Okay, this is your B1, graph B1. This is F1. So here is A1 and then here is C1. Here is E2, E9, E8, E7 and E3. Okay, so edges are given here. E3, here is also E3. E3 is a common edge. Now we'll take the union of this graph. So vertex, this is your graph G star. Okay. So union of these two graphs will be, so union of G and G star, you will get. So union, it means what? The vertex set a vertices of, it means it contains all the vertices and all the edges from the both the graphs G and G star. Okay, so we can draw the union of these two graphs is, okay, union of these two graphs is like this. Suppose this is your A1, with E1. Okay, now with A1 and E8 is also there, right? So what I will do, I will draw the graph G by using blue pen, and by other pen, other color, we will show that the graph G star. Okay, and you will get the union of both these graphs. So here is A1 is here, B1 is here, but B1, but there is an edge here. So ultimately we'll get, so no need to cover up A1 and B1. Union, it will contains both the edges. So here is the edge E6. Edge E6. Here A1 to B1 is the common edge E2. Right? A1 to F1. Here is F1. E8. Here F1 to B1. Here is E9. Right? Here C1, A1 to C1, no. B1 to C1. Right? B1 to C1. No, B1 to C1 is edge E3, and C1 to A1 is edge A1, B1. Here C1 to A1 is the edge E7, right? Here C1, E3. Now E1, E2, E3, E4, E5 is remaining. So B1 to D1, E4. C1 to D1. Here is E5. Right, now see A1, B1, C1, D1, A1, B1, C1, D1 is done. Okay. Now all the edges are done. E1, E2, E3, E4, E5, E6, E7, E8, E9. That's it. Okay. This is your G union G star. I hope you are getting it clearly how to draw the union of these two graphs. Right. So union of G and G star is this, containing all the edges and all the vertices only once. Okay. Now with the same graph we will draw, find out the intersection of the graph. Okay, so intersection of a graph. Second, intersection of graphs. Can say that intersection of graphs. For this, it means the number of vertices which are common to both and the number of edges which are common to both, that only comes in an intersection. Now if you see here, which are the common vertices? Here A1, B1 and C1. D1 is also common, but there is no edge to join in a G star. Right? So here the vertices A1, E2 and E3. E2 present in both. E2 present in both. E3 present in both. Only these two edges are common in both the graphs. So that will become in a. So you will get here A1, B1 and C1. Only common vertices and common edges will come in a intersection of a graphs. Okay. So common vertices and common edges. So common vertices are A1, B1, C1. D1 is also common. But sorry, here D1 is not present in G star. So we cannot take D1. Okay. So the only common vertices are A1, B1 and C1. Okay, common edges are E2 and E3. So common edges are E2. A1 to B1 is a common edge, E2. And B1 to C1 is a common edge, E3. Those edges which are common in both G and G star and G1 and G and G star, and the vertices which are common in both G and G star will come in an intersection. So G intersection G star. Okay. Now third one is ring sum of a graph. Okay. Now ring sum of a graph. Ring sum of G and G star. Okay, that is G ring sum G star. So in a G ring sum G star, edge set, the vertex set is A1, B1, C1, D1, F1. All the vertices are covered, but the edges which are common in both, that will not be taken in the ring sum. Okay, so which are the edges common? E2 and E3 are common edges. So except that edges, we will take all the edges. Okay, so the way vertex set you will get for this vertex set is A1, B1, C1, D1. Okay, D1, F1. All the vertices, all the sets here. A1, B1, C1, D1, F1. All the vertices will be there. And edge set E contains the edges which are in both the graphs, but which are common to both the graphs, that will not be contained. So E3 and E4 will not take, because E2 and E3 present in both the vertices, both the graphs. So we'll take E1, E2, E3 is not there, E1, E4, E5, E6, E7, E8 and E9. That's all. Okay, so we'll draw the graph. Here is A1, it means E1 is there. Here is A1, then F1, A1 to F1, F1 to B1. Okay, so here you will get B1 to D1, D1 to C1, C1 to, here is E7, you will get C1, E5, E4, here is E6 and here is E9. Okay, here is E8. Now this is your ring sum of G and G star. Okay, if ring sum of G and G star, it means all the vertices which are present in G and G star, that will be covered, but the edges which are common in G and G star, that will not taken in the ring sum of G and G star. Okay, so this is your G ring sum G star. I hope you are getting it clearly. All the edges are covered. Even E4, E7, E4, E5, E6, E7, E8, E9. Okay, so this is your ring sum of G and G star. Now next is removal of an edge. Next definition we will see removal of an edge. Removal of an edge. Okay, so for the graph G, we'll see G is equal to vertex set and edge set. Let E belongs to G. E belongs to E of the edge set of G. And then the graph G minus E. Then the graph G minus E is a graph obtained by removing an edge, E from the graph. Removing an edge from the graph. Okay, so G minus E, removal of edge. It means if you remove the edge, the number of edges which are incident on that vertex only remove. Okay, but suppose this is your graph. So we'll see the removal of edge E. This is your edge E. So after removing, this is graph G. So after removing an edge E, you will get the graph like this. So this is your G minus E. So this is an removal edge of an edge. Okay. Now removal of vertex. Next point is removal of vertex. But if we remove the vertex, what will happen? The number of edges which are incident on that vertex, that will also remove. Okay. So for a graph G is equal to vertex set and edge set E, let V belongs to V, then the graph G minus V is obtained by removing the vertex V from the graph G, right? Removal of the vertex from the graph G. Now removal of V means removal of all those edges which are incident on the vertex V. Now for example, suppose this is your graph, the same example if you take. Okay, and suppose this is your graph. Now suppose this is your graph, right? After removal of this vertex V, suppose this is A, B, C, D, E. What will happen after removal of this vertex A? So the number of edges which are incident on A, that will also remove. So you will get the graph like this. This A is removed. So you will get the graph like this. A, B, C, D. Okay, so after removal of this vertex, you will get the graph like this. So this is your G minus V. Okay, this is your graph G and this is G minus V. It means after removal of these graphs, you will get the all the edges which are incident on that vertex will also be removed. But the only removal of edge, only that edge will remove, any other vertex will remove. Okay. So I hope you are getting it clearly, the concept of removal of vertex, then isomorphism of a graph. Now we'll take one more example of isomorphism of a graph. So find whether K4 and K22 are isomorphic. Okay, one example. Find whether K4 or K22, K4 or K22 are isomorphic. Are isomorphic. So how we can say that these two graphs are isomorphic, whether K4 or K22 are isomorphic. What do you mean by K4? K4, it means complete graph on 4 vertices. Okay, so complete graph on 4 vertices. So how we can calculate the number of edges in a K4? So the number of edges in a K4 can be calculated by using the formula as we have seen in the previous lecture. Number of edges in K4 are n into n minus 1 by 2. That is here K4, n is equal to 4. So 4 into 4 minus 1 is 3 by 2. So number of edges are 6 here, right? So in a K4, K4 and K22. So number of edges in a K22, complete graph on two vertices, complete bipartite graph on two vertices. K22 number of edges in a complete bipartite graph Kmn are m into n. So number of edges in K22 are m into n. So that is 2 into 2, which is equal to 4. Now here number of edges are in both the graphs are not same. Number of edges in K4 and number of edges in K22 are not same, which implies K4 is not isomorphic to K22 because it fails the second property. Now number of vertices in both the graphs are same. K22 and K4, 4 vertices in K4, 4 vertices in K22. But the number of edges in K4 are 6 and number of edges in K22 are 4. So which is not equal. Therefore, K4 is not isomorphic to K22. By using this symbol, we can show that. Okay, K4 is not isomorphic to K22. So I hope you are getting clearly the operations on a graph. Okay, so that is first is union, second ring sum, intersection and ring sum, removal of edge, removal of vertex. So every operation you will be clear to here. So I will give you one more example. Check whether these two graphs are isomorphic or not. Okay, so we will say here which of the following graphs are isomorphic. Which of the graphs shown below, which of the graphs shown below are isomorphic, right? So here you will get so here you will get 1, 2, 5, 6, 7, 3, 4. Okay, here is V2, right? This is your graph G1. Okay? Graph G1, this is graph G2. So G2 is this vertex V1, V2, V3, V4, V5, V6 and V7. Okay, we'll draw one more graph. Here we say U1, U2, U3. This is another graph. Here U1, U4, U7, U6, U5, U1, U2, U3. So these three graphs are given. Now check whether which graphs are isomorphic. Either G1 isomorphic to G2, G1 isomorphic to G3, G2 isomorphic to G3. That we will check. Okay. Now for G1 and G2, let's check. So number of vertices on G1 are 7. Number of vertices in G2 are again 7. But number of edges in G1 are, count the number of edges. Here 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Number of vertices in G1 are, number of edges in G1 are 10. Number of vertices in G1 are 7. Number of vertices in G2 are 7. Number of edges in G2 are here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So number of edges in G2 are also 10. Now the number of vertices of same degree. Now number of vertices of degree 4, 1, 2, 3, 4 is 1. Degree 4 vertices 1. Degree 3 vertices 1, 2, 3, 4. Degree 3 vertices 4. And degree 2 vertices 2. Now total number of vertices are 7. Okay. Yes, done. Now number of vertices of degree 4. 1, 2, 3, 4. Degree 4 vertices are 4. No, 1, 1, 1. Sorry. Degree 4 vertices are 1. Now degree 3 vertices 1, 2, 3, 4. Degree 3 vertices are 4. Degree 2 vertices 1, 2. Degree 2 vertices are 2. Okay. Now here adjacency preservancy we can say. In case of G1, but G1 is not, see, number of in G1, G2 and G3 all the graphs have 1, 4 degree vertex, 4 have 1 vertex of degree 4, 4 vertices of degree 3 and 2 vertices of degree 2. Now here in G3 also we can see, check. Now number of edges are here 10. Number of vertices are same in G3, 7. Number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So edges are also 10. Degree 4 vertex is here only 1. Degree 3 vertex 1, 2, 3, 4. Degree 2 vertex only 2. You find U7. So in the both all the three graphs G1, G2 and G3, number of edges are same, number of vertices are same, degree vertex is also same. Now we'll check the adjacency preservancy. Okay. So adjacency preservancy, but in G1 is not isomorphic to G2. Also G3 is not isomorphic to G2. As in G2, 4 degree vertex is adjacent to 4 3 degree vertices. So we can write it here. All the graphs have proper way. All the graphs have 1 4 degree vertex, 1 4 degree vertex, right? And 3 4 3 degree vertex, and 2 degree vertex. Okay, but G1 is not isomorphic to G2. Why? But G1 is not isomorphic to G2. Also G3 is not isomorphic to G2. Why? Because as in the G2 we can see, as in the G2, 4 degree vertex is adjacent to 4 degree vertex is adjacent to four 3-degree vertices. Four 3-degree vertices. But in G1 and G3, 4-degree vertices is adjacent to 4-degree vertices is adjacent to two 3-degree vertices. Two 3-degree vertices. Okay, is adjacent to two 3-degree and two vertices is two with 2-degree vertices. Hence adjacency is not preserved. Hence adjacency is not preserved. Therefore they are not isomorphic. Okay, therefore G1 is not isomorphic to G2. Therefore G1 is not isomorphic to G2 and G3 is also not isomorphic to G2. In case G1 and G3, adjacency is preserved. In case G1 and G3, adjacency is preserved. Adjacency is preserved. Therefore, we can say that as 2 to U5, 4 to U7, you can see that 1 to U6 and 3 to U4. This is the adjacency relationship. 5 to U2 and 6 to U3 and 7 to U1. You can see the adjacency relationship here. See, G1 is not isomorphic to G2, G2 is not isomorphic to G3, but G1 and G3 are isomorphic. As here 4-degree vertices is adjacent to 3-degree vertices. Okay, here 4-degree vertices is adjacent to 2-degree vertices. Therefore, adjacency is not preserved in G1 and G2. Similarly in G1 and G3. But here 4-degree vertices is adjacent to 2-degree vertices. Here is also 4-degree vertices is adjacent to 2-degree vertices 2 and 3-degree vertices 2. Here is also. So adjacency relationship preserved in G1 and G3 but not in G1 G2 and not in G2 G3. Therefore G1 is isomorphic to G3 but G2 is not isomorphic to G3 and G2 is not isomorphic to G1 or G1 G2 not isomorphic, G2 G3 not isomorphic but G1 G3 are isomorphic because adjacency relationship is preserved in G1 and G3 because here two vertices are adjacent to 1-degree vertices and one vertices with 3-degree vertices. Okay, so exactly similar way, adjacency preserved in G1 and G3, but adjacency is not preserved in G1, G2 and G2, G3. Therefore, they are not isomorphic. I hope this is the best example to check whether the adjacency is preserved or not. Okay. So, I hope you are getting clearly understand that what you mean by the adjacency relationship. Right. So, how to prove that the two graphs are isomorphic? You will clear here. Now, in the next lecture, we will see here that is path, walk and circuits. Okay, the main concept elementary path, elementary circuit, walk and the best algorithm, that is Dijkstra's algorithm for the shortest path between any two vertices. Okay, that we will see in the next lecture. Okay, so I hope you are getting clearly the isomorphism of two graphs, how to find out the isomorphism of two graphs, right? So here, okay, so we can see that the isomorphism of this graphs, then operations on the graphs, everything we have covered in this lecture. So you go through it. If you are really liking my videos, please do like, share and subscribe. I will be here at the same time tomorrow with the new point of graph theory, that is path, walk, circuit and most important algorithm, that is Dijkstra's algorithm. Here we will see Dijkstra's algorithm to find out the shortest path between any two vertices. Okay, so let's crack GATE and ESE, and please you can to join our telegram group of latest updates on our upcoming videos. Hit the bell icon for the notifications. So thank you so much for liking my videos. Okay.